start and the end of this. So let's bring this up. Feel free at any point to ask me questions on that. Hopefully the Google Doc version of this should go online about 5 o'clock. I've got it scheduled. But Google Docs has been messed up all day today. So I had to spend last period putting it into PowerPoint and adding new photos and stuff in there, because 2 weeks ago YouTube was weird. This week Google's weird for some reason. So you guys are starting off Extension Science. You guys are the first to go through in this cohort, and you're all very, very, very special. I know, you are very special children. So, what are we going to be doing? Now, we went to Sydney Uni last week, and we sort of did all that stuff there. The first 2 hours, I think I was the same as you guys. First 2 hours, great. Oh, it's really good. And then stats came. Now, we'll be doing a lot of work on stats, probably not this term. This term's going to be about framing what our report is and going from there. I'm also working with some other people across Sydney and across the state on developing some stats resources as well, because I really need to get my head around it as well. So the idea of this course is that you are going to be doing, and I'll put it in brackets there because real science, okay? Because the stuff that we do with chemistry, physics, earth, IS and all that, look, in all honesty, it's not real science. We're giving you some stuff, we do a few tracks, we draw some conclusions from it, and then we just move on. Now, real scientists, and I know some of you have parents that work in science and medical. Shivam, your dad's an engineer? Fine. Yeah. And so people who actually work in industry and work in these things, they don't just do one thing and move on to the next. They go into a lot of depth, and they go back and they review, and there's a huge process. And also the scientific method that we taught you in Year 7 is a really small, narrow view. Scientists don't necessarily, develop a hypothesis, inquiry, question, then do an experiment and revise. Now, one of the doctors that spoke to us in uni gave the example of Diane Fossey. She was a biologist who works, what's the fancy word for working with primates? Anyone? There's probably a fancy word. But she didn't do experiments. She just sat there and watched. Now, it's just a different way of doing these things. So what we're going to do is I've kind of broken it down in these 5 areas. Find an area of research. So we're going to find an area that you're interested in. And so this is the thing why, for the most part, we're not going to be doing a huge amount of sit down, shut up and listen to me work, because what you do as the course develops depends on what area of research you're doing. It depends whether you've got someone that you can work with on first-hand investigations or whether you're going to be analysing a lot of second-hand data. It's really going to be flexible. What you are going to do in the next 4 weeks is find out what is known, okay? And so this is going to frame your literature review, which is you go out there, you write a 700-word thing on what people know about the area you're interested in. Now, as well, was it Professor Manju, who was the main one who spoke there? She said, don't be afraid that if you go through this process, you get halfway through it, and you change what you're doing, okay? Because that is part of the scientific process as well. So, do an investigation, primary and or secondary. You might find, that depending on where we go with your projects, you might find someone who's doing research at the moment and you can be involved in the primary collection of data. Or you might say, I'm really interested in the local ecosystem, so I'm going to do my own data collection from around here and compare it to secondary sources, okay? And that's going to, finding the information is probably going to be one of the hardest bits, particularly when it comes to analysing, which is the next bit, analyse your research. Okay, we're going to take a lot of data, we're going to analyse it. And so, again, that's very different to what we do. Like, what do we do in IS today? We did a dodgy little experiment that kind of only half worked, and we just move on to the next one tomorrow. That's kind of what we do in high school science. We move from one thing very quickly to the next, and if our experiment doesn't work, we just show you a YouTube video where it does work. okay? But you will be expected to persevere. What's this week's persistence was last week. This week's impulsivity. So think about last week's, what are those things called again? Oh, it is 19 Habits of the Mind and all that. But you can read there, learning dispositions. So last week's one was persistence. And in all honesty, that is probably one of the biggest things you guys will have to do. You'll have to keep on persisting, okay? Because things will get difficult. You find you get to bits where it doesn't work quite for you, you have to rethink, okay? And so for the most part, my job is to sort of try and help you and guide you. I'm not going to tell you how to do everything. I'm going to tell you as best as I can. As I've said to you guys before, I don't really have a research background. But there are people in the school that will be able to help you. There's other people we know around, and we can sort of work that out. And then, of course, the last bit there, in about week 6 of term 3, you then have your final report, which then you present to the world, okay, which is uploaded to NESA and all that, and we'll have marked it and gone through it and collaborated with you on all that stuff there. Any questions?
Just a report, you know how we work over the year, right?
Yeah.
Are we able to show you what we've done throughout the year to give us
Absolutely.
So does that mean people won't give me anything until the final?
Well, it's not so much you're going to be giving me. I'm going to show you something in a little bit, how I want you to start setting up your report, particularly with your portfolio on that. Because it's not going to be about handing in, and I think I've worked with a few of you on Google Docs and stuff before. Okay, and so we're going to be doing that, and it's going to be sort of that more collaborative thing there. You can just send me a message saying, can you look at this, and then we go from there. Okay, any other questions? Okay, now here is possibly the hardest step. Okay, step 1, what area? What are you going to do? Now, I know most of you I've had discussions with, and we've got a bit of an idea, and you think, I'm thinking about this. Now, remember what we talked about the other day in the uni, which is they said, and I think I've said this to you, you start big and then you come in. So the first thing, I'm going to have you think of a couple of questions. What science courses do you do now? Now, of course, my spelling's bad, and I define it. No, I won't. So what science courses do you do now? No, I've talked to you. I think a good portion of you do biology. And we've got people in here who do every single course. So we've got a wide range. Okay, I think the majority of you, it's probably bio and chem, and that there. Now, the other thing to think about, do you do other courses that might help you? Now, the two I've thought of, I know one of you do PD/HPE. Now, some of you probably would notice that there's a bit of overlap between PD/HPE and biology. There's also a bit of overlap with chemistry and a tiny little amount with physics. So if you do that, there. Geography, there is a lot of overlap with earth science. There's a little bit of overlap with chemistry, although the geographers probably say, oh, the water's bad, they don't do the test, they just say it's bad. But, you know, that happens when you're in a faculty that colours in. But also, do you have any outside experiences? You know, as I said, there's a lot of kids in this school, you know, because we have the half selective thing there. There are a lot of your parents who are scientists, who work in medical areas, scientific areas, engineering, these things like that. Are there things outside that can help you? Okay, and that's something for you to think about there. Now, of course, I think most of you have sort of said you've got a bit of an idea. Okay, are there any questions about that? Okay, so the area, think big. And then after that, we bring it in, because what you're going to do after that is this little bit here, step 2, what is already known. So what we're going to do, and this is going to be something you need to do, so we're in week 3 now, you're going to be doing your first assessment task in week 7. Okay, now you've got the notification online for that, and so what you need to do between now and week 7 is conduct a literature review. Now, what I'll do next week is I'll go into a lot more detail with that, okay, on how you actually do it. Because what you can do now is you can still do all your wide research, find out as much information as possible. The literature review takes all that information and condenses it. Okay? So do a broad search of the scientific ideas. So if it's biology, this, that, or the other, it doesn't really matter. At this point here, you're just collecting as much information as possible. Now, of course, one thing here, depending on how old your teachers are, teachers of a certain age will say, never look at Wikipedia. I'm not one of those. Wikipedia is a great starting point. 99.9% of the scientific stuff on Wikipedia is correct, because the nerds who do the writing of this, like, you think you guys are nerds? They are uber nerds. They will fact check everything. And if someone puts anything that's incorrect on there, then the Wikipedia nerds are on it, like, you know, like a seagull on a chip. They are just onto it straight away. Science stuff on Wikipedia is more accurate than looking at an encyclopedia or looking at a textbook. Because I can tell you from my experience writing textbooks, there's probably about a dozen people look over the work before it's published. Here, there's probably 100,000 people looking at this work. It's accurate. But there's another thing you can do is look down the bottom. Now on this page here, I've just taken a couple of grabs from a climate change one. And right at the bottom, Wikipedia is absolutely really good at citing the sources where the information comes from. Now, a few people, like, I didn't go to university in the internet days, but a few of my colleagues who have been to uni in the last 10 years will tell you that one of the best ways to get information for a uni assignment is you look at the Wikipedia entry and then you think, okay, let's have a look at this little thing here, the United Nations Framework, Convection and Climate Change. These are all links to the sources. So by looking at these things here, you might be able to find some first-hand sources of information. Now, things that are published like the United Nations, UNESCO, NASA, any of that stuff is usually published for free. The other thing you can do as well is if you find, because unfortunately in the scientific world, a lot of journal articles get behind paywalls and you've got to pay $50 to get this article. For the most part, if you actually email the person that wrote it, they'll probably send you a copy of it if you can't access it, or you can access the information from other places there as well. Okay? So I would suggest, as a starting point, the Wikipedia page for the area you're looking at will give you all these branches to look at. And in fact, it's probably better to do this, and you know, there'll be a million teachers out there that'll be yelling at me for saying this. This is better. This would probably a better starting place than Google, because Google's based on all these stupid algorithms and its popularity and all that stuff there. Okay? So the main thing here is that you guys have got to get in the habit of going beyond the first Google search page. This will help you, I think, to that, doing that there. Okay. Any questions? You are free to ask questions and interrupt me. Look, I've marked 1 million assignments in the internet age, and it's so easy to pick up plagiarism because people who plagiarize generally do not go past the first 10 Google search entries. The other thing, and even though I am going to broadcast this later on, the easiest way for someone to check if you plagiarize is you just copy the first paragraph, put it into Google, that article will pop up as the first entry. The number of times I've caught kids doing that is ridiculous. But that's the thing. The amount of information you're going to collect, you're not going to be able to do it with this assignment, with the work we're doing here anyway. And look, and honestly, in the end, you guys will go to university and you already have half the skills that are so much better than everyone else there, other than the other 1,000 kids who do this course. Now, do an investigation. This is the big bit. This is what we will start thinking about at the end of the term. So once you've done your literature review, you will have an idea of what you're going to do. You'll develop your inquiry question. You'll develop your hypothesis. And we'll do that there. We will not start talking about p-values or anything like that until next year. So that's fine. I'm giving you a break on that. That's all right. I'll show you a couple of things at the end of this as well. So in all honesty, most of you will probably be looking at second-hand data. I did a little thing today, and I, had a look at CERN. So CERN is the Center for, you normally remember this. It basically runs the Large Hadron Collider. And all their data sets are open to the public. So if you wanted to find data about the Higgs boson, which is the big particle discovery, all the data is freely available online. Now, those experiments generate so much data. You can analyze it. Good luck to you.
What's that
CERN. It's French. Europe, I think the E's Europe, they are probably
Organization for Nuclear Research.
Yeah. Basically, it's an experiment that costs $20 billion to make and about $1 billion a year to run. And, at some stage when we talk about ethics and stuff like that, actually we talk about that in IS as well. When we talk about the ethical side of things, it's like, well, people will say, well, is it ethical to spend $1 billion on research, fundamental research every year? That's about what the US spent a week on weapons. And if you look fundamental research, you don't know what it's going to produce now, but you may in the future. Just that there. What was it? Was it that Sydney the other day they were talking about? Wi-Fi has come from black hole research.
Yeah.
Yeah, but fundamental research from 50 years ago may lead to a new technology in the future. You just don't know. Now, of course, data analysis, which is the one that we're all looking forward to doing. Okay, my IS guys, you'll have already done a little bit that when we did that climate change thing, and we destroyed the computers in the library because they couldn't handle a spreadsheet with 40,000 data points in it. It eventually did it. It just took about 5 minutes to calculate the data. But this is why places like CERN and NASA and all that have these massive supercomputers so that they can churn this data. And it's like, you think about the number of radio telescopes on the planet and all that, there's so much data coming in. And you look, this is where most of modern science is really done, is in analysing the data. Was it the maths professor from the other day? She was talking about the fact that, data science is probably the forefront of science at the moment. Because that's where it's done. Like the Human Genome Project, all the data for that, I think, is available online. And so that's one of the things we'll be developing over probably in the next few weeks. We'll search for areas where you can find it. And also where you get correlations. So the idea of doing all this data is to find a link, a correlation. The other interesting thing is when I searched for people in lab coat, there was a whole bunch of white people. So very interesting little thing there. In terms of the ethics background there. It's like, most of the science in the world is being done in places like China and that. And you search for people in lab coats, it's all white people. Although she doesn't look very happy. And he looks a little creepy. Oh, don't give me that crap. And as I said, a lot of the science is people sitting in front of computers. Although people sitting in front of computers, you at least get one Asian girl there. So there's diversity. Of sorts, yes. Let's see how we go with this. So, I want to quickly show you just a little video, just to be careful of what happens. Of course, you guys can't hear the sound. I can hear it in my ear. And you can't actually, that's all. You can't see anything up on there. You know what I've got to do? I'll get out of it.
So the theory of it has been proven, but the practical analysis has not. So would that apply to both secondary and primary research?
It would really depend. We'd have to sit down and have a look at that. Because one of the main things is it's you engaging in the scientific process. And in all honesty, and that's not having a go at anyone here, it's going to happen every so often that some kid will discover something new and fantastical. But for the most part, is you won't. You'll either confirming something or looking at something in a different way. The process is the important thing. Whether you discover some new particle out of the CERN data, that's awesome. You might win a Nobel Prize, but it's not going to get you top marks in the HSC. Now, we could argue which one's more important, but it's what the HSC is. Okay. So, final bit is presenting your research, which for you will be the report, and I think it might be early term 2, you'll also be presenting your known data as you have it so far, like these little munchkins down here. No, I'm talking to a lot of the people I'm working with. We don't think a speech will be the thing. Apparently this is it's like the American style science fair thing. And what will happen is that you'll have something like a poster. And that poster will have all your information and all your findings so far and blah, blah, blah. And then we'll have people like university academics asking you questions about your research. Yes, you will be. But the idea is that it's not a speech. It's just a one-on-one conversation with the people there. And there'll be a ton of people doing that, and then we'll probably aggregate the marks and that there. But the idea is that you can show a bit of understanding about what you know. Okay. But I reckon by the time you get to that, you will. Because you'll have your head so far into this data and all that. And the process should actually get you to a good place in terms of the way we do that there.
Also,
Yes.
not related to that, but more towards the HSC side. How long do you think this whole cohort is going to be?
I really don't know. Because the exam itself is going to be quite different to what you're used to. It's the first HSC online exam, and you'll have your report there. The questions will be asking you stuff about your report. And so who knows what's going to happen there, but it's going to be an interesting exam because it's not about if you can remember this concept. It's about how well you explain your understanding of it. Okay, so we'll do a lot of practice questions beforehand. We'll do a lot of guessing on what the final exam might be like. Trying hard not to burp in the microphone. We don't know, and everyone's in the same boat. All I can say is that if you've gone through this process for the year, you should know, and you're basically going to be talking about your project.
Will it be different? Will the questions be different for everyone?
No, they will be the same. Because one of the things we'll look at is that the NESA have put down guidelines for what your report will be like. So it's titled abstract. I can't remember. But what it'll be is there'll be questions like I could see there, we talked about stats the other day, and, I wouldn't be surprised if they put a question on how did your p-value confirm or refute your hypothesis.
So would we have information for that? Or would it be
I reckon it would already pretty much be in your report. Yeah, because your report will say, here is my p-value. I've analysed my statistics like this, and this.
Is it possible that two or more people ask you the same topic, or maybe you do the same thing and have different?
That I can't see off the top of my head, but I don't think NESA like that. The idea is you can do some similar overarching ideas, but you would have to approach them from very different positions. And that's something it doesn't matter for your literature review and that. So for this first term, it doesn't matter, but it will when it comes to writing your reports and doing your research and that there. But the good thing is that even if you're looking at the same sort of area, there is so much data out there for free that it's very easy for you to look at different aspects. And that's sort of a one-on-one conversation we can have anyway. Okay. So here is going to be where I'm going to try and be really clever here. Okay. Because if you get nothing else out of this course other than awesome marks, and I don't know what the projector is going to be funny there, is this idea here. Now, this is a really important point, and it's sort of the last point I'm going to talk about before I get you to do a couple of things, is what does this mean? Correlation does not imply causation. What was that? Vaccines do not. No. That is absolutely correct. Yeah. No. And, I can't remember the guy's name. Dr. Wakefield. Yeah. Is it Andrew Wakefield? No. Okay. Yeah. So Andrew Wakefield was a British doctor, I think in the late 80s or early 90s. He published a paper in one of the biggest medicine journals in the world, The Lancet, saying that he had found a link between autism and the MMR vaccine. And so his evidence was, well, kids get the MMR vaccine, I think, about 18 months, and autism at the time could be detected at about 20 months. And he did this here. Now, unfortunately, what he did is he didn't analyse his data very well. And it took about 20 years for the Lancet to retract his article and say his findings were wrong because he only used a very small sample of kids. And what had also happened in the meantime is the diagnosis for autism went from being at about 20 months, and I could be wrong on that exact thing there. The diagnosis of autism is actually done much earlier. So kids are now diagnosed with autism before they would get the MMR. So what it is it's just the fact that there was a coincidence that the MMR was given 2-3 months before autism could be verified. But this guy has made a fortune. He goes around there, and of course, stupid people across the world, your Facebook posts about, oh my God, don't put vaccines in you, it kills you. There are very rare cases where a vaccine will cause harm to a person, like 1 in 100,000. But what would happen if we took away the measles vaccine? Yeah. 100 years ago, half of you would have already been dead due to measles, whooping cough, polio, diphtheria, any of these diseases. Half of you are alive because modern medicine has found a way to stop these diseases from killing you. A good portion of you probably also would have died in childbirth as well due to complications, and your mothers would have died. That's the reason the average age was sort of younger years ago was usually because it was hard to survive your first 5 years. Okay, a lot of things there. Now, of course, correlation does not imply causation. Just because something kind of looks as though they're related doesn't mean they are. Now, of course, the internet has a plethora of awesome things like this. And so one of my favorite sites to look at is this one here, which links what it calls spurious data. I think they did at UCID, yeah. Similar thing here. So like here, this is the data. Now if you look down here, the correlation is 0.92. That is really correlation-y, whatever the word is supposed to be there. So this is drivers killed in collision with pedestrian or animal. That is worldwide. So in 2007, in the US, I think this is US data. So deaths in the US, I don't know where the 18.33 comes from, but around 20 people in that year were killed by colliding with an animal, pedestrian. So that's drivers. So you're driving your big truck in the back end of Arkansas or something, and you hit a moose. And there's Arkansas is pretty redneck, and there's no moose anywhere near it. But anyway, you hit a big animal, you're the driver, you die. But if you collate that data against lawyers in American Samoa, there is a very, very big correlation. Do those things cause each other? No, they are completely separate bits of data. So you've got the reason stats is a big thing in this is so that you don't take readings out of context. I've got a couple more here. Drivers killed with a pedestrian or animal, again, with copies of video games sold in the UK. Very good correlation there. In fact, this is a better correlation than the last one. Although the first thing I see when I look at this, I say, well, the data's probably flawed for other reasons. How many years are there? Oh, 3. Got to count that one there. 1, 2, 3. So 3 years is not enough really to have a causal link anyway. And so things like that. Of course, the best example of this is this one here. Drownings in pools versus Nicolas Cage films. This isn't quite, this is sort of, I think this is one of the famous ones there. And, you know, there's a reasonable cause, there's a reasonable correlation between the data. But there's absolutely, Nick Cage is not making lots of films and going out and killing people. Well, as far as anyone's been able to approve. Okay? So that's an important thing to realize, that, you know, data is important, but data is not the be-all and end-all. One of the problems with statistics and data, and this is what happens in everywhere in the world, really. I was going to say Australia and the West and the US and that. It happens everywhere, is that people can take things like this and draw what conclusions they want out of it. It doesn't mean that it's right. And that's what science is about, is saying, well, we see this link. How do we test it? Do we lock Nicolas Cage up and stop him making films so that no one drowns? I guarantee we lock Nicolas Cage up, people will still drown in pools. Okay? So there's no causation. There's no correlation, really. Okay. Do you guys have any questions? Okay.